Hi, my name is Aaliyah, and today I will be doing a presentation about aerospace engineering alongside my classmates Liam, Cordell, and Colton. All right, let's get started. First, I want to talk about who we are. So, we are a branch of mechanical engineering that also includes electrical engineering when it comes to building circuits and software. We also design and develop machines and mechanisms to enable and enforce air travel. We work on, space, satellites, and defense systems, as well as practicing the application of physics, science, math, and critical thinking. We use this to design complex calculations. Our mission is to design, build, and test aircraft, spacecraft, satellites, and missiles to ensure their safety, performance, and efficiency, while also driving innovation towards the expansion of aviation and space exploration. The vision for us is going to be to advance human exploration and transportation through the advancements of technology. So there's kind of like two sections in aerospace engineering. There's aeronautical and astronautical. Just to be a little bit brief about it, aeronautical is everything in Earth's atmosphere, being planes and military airships and helicopters, compared to astronautical or aerospace, where it's everything in the outer layer of the Earth's atmosphere and beyond, so space. And this would include rockets, missiles, and satellites. And that is the difference. And then our history. So aerospace engineering can be dated back all the way to 3500 BC with the Sumerian king Etana, who is featured on a coin depicted flying on an eagle's back. So the concept of flight has been an ongoing phenomenon since ancient times, and throughout history of aerospace engineering, from the Chinese inventing kites to carry men to scout troops, all the way to the late 1800s, early 1900s, when the Wright brothers and other inventors took action to make and produce a new age of complex metal airplanes. And now, in our modern age, we have commercial air travel and many significant advancements in spacecraft and space exploration. Aerospace is a constant ongoing advancement where we continually discover new ways to improve air travel and space exploration while enhancing the comfort and quality of experience for those who use aircraft, satellites, and other related technology. And then you can see down below, if you want to take a little peek of the timeline that I made, it goes from all the way from 1000 BC to current dates, but the current date, there's way too many advancements that have been made for me to fit it all on this page. Yeah, and that concludes my section.
The education to become an aerospace engineer is not much different than what it would be for any other engineering major, which would be to specialize in aerospace and follow through everything like that. However, you can major in more generalized like mechanical and electrical and follow that into the professional field if you would like. A master's and doctorate is also possible, but it is not exactly required, but could help you get a higher salary. And then to go to these colleges, it would cost about $10,000 to $40,000 a year with an extra range depending on the college and the scholarships required. Furthermore, there's different licenses and certificates you could follow, like the professional engineering exam or the professional engineering license, as well as the certified aerospace engineer or certified systems engineering. These are all things that you could pursue but aren't always required. Next up would be the universities. The top five universities are listed here in order from number one, Massachusetts Institute of Technology, to the tied second place, California Institute of Technology and Georgia Institute of Technology, and then Stanford University and Purdue University. And these five universities are all ABET certified and some of the greatest you could attend. Next up would be the internships offered. Boeing and NASA are two big ones that we did see. And these all these would expect you to have, generalized things, but some of them are more college related versus, entering into the field outside of like, a college atmosphere. Like Boeing offering a quality engineering and faculties engineering program here. However, NASA offers more of like the Moon Print Solutions undergraduate program as well, and like the fall internship more centered around a like college aspect. And so these companies would actually expect you to move out to wherever their manufacturing plant or something like that is, but they would offer housing and usually pay you about 21 to 42 an hour to give you a living wage. And they would expect you to do some pretty, menial tasks that would, be expected of any engineer. Next up would be the current projects we're working on, and that would be Artemis and the Dragonfly, both by NASA. The Artemis is more towards exploring the moon with crewed and uncrewed, space exploration and producing a lunar space station. And then the Dragonfly is a, sampling machine to fly across the Titan and, try and get an actual in-depth understanding of the place.
Hello, everyone. My name is Cordell Hubbard. I'll be covering 4 slides. First slide is going to be on technical skills, and first one is going to be hard skills. So hard skills are basically measurable abilities. You can be graded on it. You can be tested on it. There's standards and procedures on how you'll actually require these hard skills. So some hard skills are going to be mathematics, physics, aerodynamics, propulsion system, material science, structural analysis, avionics, CAD, MATLAB, system engineering, flight control systems. And soft skills are more interpersonal skills. These are skills you develop to better able communicate, problem solving, creativity, leadership, time management, adaptability, attention to detail, and critical thinking. These are skills you most likely will develop as you work, basically gain experience, while the other ones you probably can learn through a book. Next will be job titles and sites. So we'll go through job titles, system engineers, avionics engineers, propulsion engineers, flight test engineers, design engineers, and structural engineers. These will probably be the most aerospace engineers will fall under, and they will mostly work in offices, manufacturing plants, and laboratories. Some companies that are very heavily orientated in aerospace engineering is Lockheed Martin, Boeing, Airbus, Northrop, GE Aerospace, Honeywell's, Rolls-Royce, SpaceX, and Collins Aerospace. Salaries and grows. So starting salary for aerospace engineer is between $60,000 and $80,000 annually. For a mid-level engineer, it would be between 100,000 and 130,000, but this takes up to 6 to 9 years. And senior engineer salaries average of 205,000 per year, and that takes about 10 to 15 years.
The answers to these interview questions were provided by an anonymous faculty member at SCC. He has a bachelor's degree in civil engineering and a master's degree in mechanical engineering. He works as an R&D S&E mechanical engineer. Here are the answers to the questions he was asked. The first question was, what does a typical day look like in your role? He responded, quote, every day is different. Some are filled with meetings, internal, external, impromptu, while some are less structured and allow time to focus on project work. The most important thing is to keep priorities in check and keep the calendar up to date. The second question he was asked was, what is the most important skills and qualities to have in your field? The most important skills on my field and in engineering in general are to never stop asking why and to always be accountable to yourself and your team. The third question he was asked was, what is something you wish you knew before you started? He responded, don't be afraid to speak up and ask questions. Chances are many in the room are having the same thoughts. The fourth question was, what is the most rewarding part of the job? He responded, making a difference. Even if my contributions to the overall mission are small, knowing that if they didn't get completed on time or accurately would cause major issues keeps me motivated. The final question was, how does your role fit in with the rest of the company? What other positions do you often interact with? He responded, my role is to ensure that the transfer from product to design to full-scale production is a seamless process and requires knowing the original design intent along with the current manufacturing hurdles that our vendors face at any given time. I coordinate routinely with my company's design engineers, external vendors, program management, and business teams to stay up to speed on the latest developments and provide assistance so that we meet schedule. My biggest personal takeaway from the interview was the emphasis on seeking clarity and understanding. A good engineer isn't someone who knows everything right away, but someone who's passionate about seeking knowledge and understanding.